All right, let's take a look at the comments on the section 2.2 written homework. First off, problem number 1. We have a polynomial in factored form and we're asked to identify the zeros and multiplicities. I want to point out that only the factors that have a variable in them can change their values and possibly become 0. For example, x plus 3, x equals 3, negative 3 is the 0. And you see the work, setting x plus 3 equal to 0 and solving, you get x equals negative 3. Similarly with the 2x minus 1, set it equal to 0, solve for x, there's your 0. But the negative 2, there's no x value. And so that can't equal 0. The students assumed that it was x equals negative 2, but everywhere else they put the factor equal to 0. If you tried the factor equal to 0, you get negative 2 equals 0. And that's not possible. That would give you no solution. Therefore, it wouldn't contribute a 0. Now this messed up the graph and everything else, and the student's going to probably correct it. But I wanted to point out that a constant cannot equal 0. It's equal to whatever it is. Okay, this is a wonderful format for listing the zeros and multiplicities in a table format, but there are a lot of other ways. This also listed the x-intercepts. Okay, now, this next one. We have the y-intercept is when x equals 0. The work looks great. The only thing different is they don't have this in a y-intercept form. They could have listed y-intercept equals 0, but the y-intercept is just negative 6 if you're going to have y equals. The 0 is the x value. So like they have the intercepts for the x-intercepts in point form, they should have had the point form here. So corrected, this should have had this without the x or the y equals, just that. Or the other option is the y-intercept, something like that. That would be acceptable as well. That's not very, what the heck's up with my 6's? There we go. So those two, but the equation form that they had is not, that's a solution of an equation, not a y-intercept. Small things, I know, but it's still, we want to make this we want your work to communicate as clear as possible. Now, identify the x and y intercepts. Y equals negative 6, x equals negative 3, comma 1/2. Again, these are equation forms. In context, identify the x and y intercepts. I gave this full credit, but it would still be best to have a label like y-intercept colon and x-intercept colon, because it's not obvious without the point form and the zeros in the correct location that you're looking at intercepts. So you have to label them. The context of part B, identify the x and y intercepts. Okay, I get it. I gave full credit. Now for the graphs. This one has nice labeling of the tick marks on the y-axis. However, there is clearly an intercept, and right there would be the other intercept because this student has the graph going above the x-axis. Furthermore, crossing. And so this would represent two x-intercepts, each with multiplicity 1. That's not what they had on the rest of it. They had correctly one x-intercept right there, multiplicity 1/2. Multiplicity 2. There's no 1/2 multiplicities. Here they have, it just didn't quite get up high enough. Furthermore, they have their y-intercept. I can't really see where it is. It's like half of 15, which is like 7-ish, 6-ish. This just needed to be labeled negative 6, which is the correct y-intercept. We look at the other graph. It is nicely labeled. Well, they don't have the negative, but I'd forgive them. It's pretty obvious. But this one doesn't have any x-intercepts over here. Furthermore, the x-intercept here at negative 2, it's actually crosses at negative 3. And in order for them to get this point, which they had correct from plotting, I believe, to up to here, they had to go almost vertical. Functions don't go vertical like this. They might appear to, but they don't. So a couple of issues on this one, as you can probably tell. Which leads me to a very nice looking graph. Very nice looking graph. The only issue here is, what is that? I can't tell. So clearly the distance between 1 and 2 and the distance between the tick marks on the y-axis are different. So I know the y scale is different from the x scale. So I can't assume the numbers on the x scale are the same as the numbers on the y scale. This could be 10, 20, 30, 40, 50. I didn't mean to move that. Like this problem, they labeled them 15, 30, 45, 60, 75. That's a great labeling. And it's clearly different from the x-axis. Here, there's no labeling at all. So this student either needed to label -1, -2, etc., or labeled just this at -6. Or in fact, they could have labeled this as a point. Oh, and that's not right, is it? Either way, one way or the other, labeling a point, labeling the value of the tick mark, or giving the pattern of the tick mark values, somehow this needed to have a y-axis label. Other than that, it was probably the best graph I saw. Very good work. Overall, not a lot of issues. Hopefully this clarifies any comments that I have. Please feel free to fix your work and resubmit it for full credit.